So we're going to look at chemical formulas, specifically ionic formula writing today. Let me just remind you that chemical formulas consist of the symbols for each element and the subscripts indicate the number of atoms present in the compound. When you see a chemical formula, it represents a compound, or we could also call that a molecule. Recall that the definition of a compound is when two or more elements chemically combine, so they've gone through a chemical reaction and they've bonded. They can either share electrons, like with your covalent bond, or they can transfer electrons, which is what happens with your ionic compounds. Keep in mind that compounds are neutral, which means they have an overall charge of 0. So specifically with your ionic compounds, that's important to remember because we always want to make sure that our charges cancel and our overall molecule or formula is neutral. Now, when you're thinking of ionic formulas, you want to remember that because they're called ionic, they do consist of cations and anions. Remember, cations are positively charged ions and anions are negatively charged ions. Our metals form cations and our nonmetals form anions. I want to focus for just a few minutes on the types of ions that we will encounter. So we have monatomic ions. Mono, remember, means one. Here we see the root word atomic, which refers to atoms. So monatomic ions are single atom ions. Now, of our monatomic ions, we have two subcategories. We can have monovalent ions, which these are your ions that only have one possible charge. Mono again means one. Valent refers to their valencies or their charges. So monovalent ions have only one possible charge. The good news is we already know which elements are monovalent ions. We learned in the last unit of a pattern here that our representative elements follow. So we learned that as a general rule of thumb, all the 1A's form a +1 charge. The 2A's form a +2 charge. The 3A's are going to lose 3 electrons and form a +3 charge when they form their ion. And the group 4A's, remember, there are some that are +4, some that are -4. The 5A's are -3. The 6A's are -2 when they form their ion. The 7A's are -1. And remember, the noble gases are already neutral, so there's no reason to gain or lose electrons, so they don't form ions. This pattern is observed with our representative elements. So there's our monovalent monatomic ions. Now we also have monatomic ions that are multivalent. Multi means multiple or many, and valence refers to their charges. So they have more than one possible charge. Most of these are going to be our transition metals. Now there are two transition metals that are not multivalent, they're monovalent. So that's zinc and silver. I'll show you how I remember that shortly. And then we have two of our representative elements that are actually multivalent. So tin and lead are the two representative elements that are multivalent that we need to remember. Now, all of the transition metals except for zinc and silver are multivalent, but on this slide, we're going to look at some specific ones that I want us in our class at this point to focus on first. So remember, multivalent ions have more than one possible charge. There are some that are +1 and -1. The element that is +1 and -1 is hydrogen. He can be a +1 charge or a -1 charge. This is the only one that can be a cation or an anion, is hydrogen. Then we have copper and mercury that can be a +1 or a +2. So Cu with a +1, Cu with a +2. Hg with a +1, Hg with a +2. I'm going to come back and talk about mercury in just a second. All right, iron, chromium, manganese, and cobalt. They are the 4 transition metals that I want you to remember that are going to be a positive 2 or a positive 3. And then, of course, I mentioned tin and lead. Tin and lead are both +2 or +4. Now, when they're multivalent, remember from the homework we did over the weekend that in naming those, we use Roman numerals to specify their charge. So, for example, if we wanted to name cobalt with a +2, we would say cobalt, and we would put a Roman numeral 2 ion. That Roman numeral represents his charge. If we were referring to cobalt with a +3 charge, we would say cobalt Roman numeral 3 ion. So we use, this is called the stock system, and it's where the Roman numeral represents the positive charge on the cation. So here we would call this lead 2 and lead 4, tin 2 and tin 4. Now mercury is kind of funny, this mercury 1 ion. This is mercury 1. This is what you would think the formula would be, but in actuality this is not correct. But I wrote it this way just so that we could talk about what you would expect it to be and what it really is. Mercury 1 is very unstable like this. So what happens, this is how I remember it. Mercury 1 is very lonely. So it has to find its twin. So think about if Mercury 1 and another Mercury 1 were to get together. They look just alike. They're twins. So the only way that they're stable is if they both come together. And so how many Mercuries would we have here? That's right, 2. So you'd say Hg, and we represent that there's 2 of them with a subscript 2. Now look at their overall charge. Their combined charge, +1 and a +1 is going to be a +2. This is actually the formula for the mercury 1 ion. Just remember, it always has its little twin with it right there. That's its twin. There's 2 of them. So this is mercury 1 ion, and this one will be called mercury 2 ion. That's the only kind of anomaly we see there. Now, I told you that zinc and silver were the 2 transition metals that are monovalent, meaning they have only one possible charge. Zinc's always a +2 and silver's always a +1. And here's how I remember that. If you look on your periodic table and find aluminum, he's in group 3A, and we learned that he always forms a positive 3 charge. Now, follow it backwards like a backwards stair step. You find zinc and then silver, so step it down. Aluminum's +3. Zinc's a +2 and silver's a +1. +3, +2, +1. So that'll help you remember silver's charge and zinc's charge if you look at that pattern, +3, +2, +1. Finally, we have our polyatomic ions, and there's a list of 22 that I gave you to learn. You just need to memorize those. There's many, many polyatomic ions, but I gave you 22 of them to learn. Okay, that's our introduction to our ionic compounds. We'll look at formula writing next. That's all for this lesson.